Hello everyone and welcome to the session number 1 of our course Database Design and Implementation. I'm Dr. Loubna Ali and I will be your guide as we dive into the world of databases, a vital part of almost every software system today. Whether you are working on a simple app or a large-scale platform, understanding how data is structured and managed is essential. Today we will cover what databases are, why they matter, their key components, different types, and how they evolved into what we use today. Here's a road map for what we will be covering in this session. We will start with the first section about the definition and features of a database. Then we have the types of databases, components of a database, evolution of databases. Each section builds your understanding step by step from basic concepts to practical knowledge. Let's start with the core question. What's a database? A database can be defined as an electronically stored, structured collection of data, such as names, images, videos, or numbers, organized for quick access and management. To handle that data, we use a database management system, or DBMS, which allows us to store, retrieve, and manipulate information efficiently. Databases are the backbone of modern applications used in industries like finance, healthcare, retail, and technology. Why are databases so powerful and widely used? Sure, because of their essential features. Organized data storage. Data is arranged in structured formats like tables or documents. Efficient access. Advanced queries retrieve data in milliseconds. Security and scalability. Databases are designed to protect information and grow with your needs. And now, before we look inside the system, the database, let me introduce the 5 main components that make up every database. Here we have the data, Schema, DBMS or Database Management System, queries, and users. And as you can see, I put DBMS in the middle because DBMS is the manager of the database. It controls all the other components of the database. We have named the 5 core components. Now it's time to understand their individual roles within the database system. Let's start with the data. You can imagine the data as the star of the show. It's the actual content being stored, like customer names, like prices or locations. Think of it like raw ingredients in a recipe, essential and varied. Schema is the master architect. It defines the structure of your data, like tables and relationships, acting as the blueprint that ensure everything is organized and logically connected. DBMS, the control center that runs and manages the entire system. Tools like MySQL, Oracle, and MongoDB ensure data is stored, accessed, and secured properly. By the way, in our course, we will use MySQL as software to build and work on our databases. Let's go now to the queries. The detective squad using SQL. SQL, it's structured query language. Using SQL, we can ask the database specific questions like show all customers from Berlin, for example, or update the stock quantity. Users are the community interacting with the system. This includes developers, database administrators, analysts, and even end users accessing data indirectly through applications. Now that we understand what makes up a database system, it's time to explore different types of databases out there. Each type of databases is specialized for different situations, from simple records to complex relationships and real-time analytics. Let's know more about these types. Here are some of the most commonly used databases in the world today. Okay, we will start with the most familiar one, which is this one, the relational database. Relational databases are the backbone of traditional data systems. They organize information into structured tables. Think of it like Excel, but more powerful and dynamic. With SQL as the language to communicate with the data, relational databases are used just about everywhere. A popular example of the relational database is MySQL. I already mentioned it, which powers platforms like WordPress and even parts of Facebook. But unfortunately, not all data fits into tables. That's where NoSQL databases come in. These databases are designed for flexibility. They can handle unstructured or semi-structured data such as JSON documents and even multimedia. A great example about this type of data bases is MongoDB, which is widely used by companies like Uber for real-time, large-scale applications. Next up, we have the object-oriented database. Okay. This is ideal for developers working with object-oriented programming languages. Instead of storing data in rows and columns, these databases store entire objects, just like in your code. One well-known example about object-oriented databases is the DB4O, which is often used in embedded systems and simulations where modeling real-world behavior is key. And finally, our hyper-connected world, we cannot ignore the cloud databases. These are built for applications that need to scale fast and be available globally. Cloud databases like Amazon Aurora lets companies like Netflix store and access their data across continents with low latency and high availability. And now that we have explored the core types of databases, let's take it a step further. There is a whole range of specialized databases that are designed to tackle unique challenges. These aren't one size fits all, each serves as specific purpose in specific industries or use cases. Let's walk through them. First up are hierarchical databases. These store data in tree-like structure. Think of folders inside folders. They are ideal for highly structured, predictable data like a company's internal organization chart or government records. I already mentioned one very famous example about this, which is IBM IMS, which is still trusted by large banks and financial institutions today. Next, we have graph. I'm not following the order, but it's not a problem. We have graph databases. These are built around relationships. They shine in situations where connections matter more than individual data points. Think of social networks, recommendation engines, or fraud detection. For example, Neo4j helps companies like LinkedIn map how users are connected to each other. Then there are centralized databases. In this step, all the data lives in one place. One server, one location. It's simple, cost-effective, it's cheap, and perfect for small organizations that don't need global infrastructure. Picture a local HR system where everything is managed on site. Now you might be wondering, didn't we already mention cloud database earlier? Yes, but here let's zoom in on the cloud native solutions like Google Firestore. These don't just live in the cloud, they are built for it. They support real-time syncing, offline access, and scale effortlessly across regions. They are ideal for mobile applications, chat applications, and collaboration tools. Then we have the data warehouses. Unlike operational databases, these aren't built for day-to-day tasks. Instead, they are designed for analytics. This is where data is aggregated, cleaned, and transformed, ready for visualization tools like Tableau or Power BI. Think of it as the engine room behind business intelligence dashboards. Lastly, let's talk about operational databases. These are your frontline systems managing live data in real time. Every time you make a purchase online, check your bank balance, or book a ticket, you are interacting with one of these databases. A popular choice here is PostgreSQL. Thanks to its speed, reliability, and support for complex operations. As you can see, databases aren't just a single thing, they are a whole ecosystem. Choosing the right one depends on what you are building, who you are building it for, and how your data behaves. Before we wrap up today's session, let's take a quick walk through the evolution of databases. Because to understand where we are going, it helps to see where we have been. In the beginning, everything was simple, maybe too simple. Data was stored in plain, flat files. No structure, no relationships, just lines of text in a file. It worked for basic storage, but managing and searching through the data was manual and very, very difficult. If you want to find one record, like one employee, one student in a book, so it's very, very difficult and time cost. Okay. Next came the breakthrough, the hierarchical model. Think of it like a family tree. Data was organized in parent-child relationships. Okay. Example, IBM IMS. It was very, very suitable in several industries like banking and government. Then came the revolution. Relational databases flipped everything on its head. Instead of rigid trees, we had tables with rows and columns, and data could be linked flexibly through keys. Okay, we got SQL, a standard language to interact with our data. This changed everything, making databases more powerful and easier to work with. Many systems today still rely on this model. Fast forward to the internet era. Suddenly, we weren't just storing names and numbers. We had tweets, videos, sensor data, user comments, all in real time and often unstructured. Traditional relationship databases couldn't keep up, so NoSQL databases were born. They offered speed, flexibility, and scalability, and they are perfect for social media, big data, and cloud applications. Now we have entered to the era of cloud-native databases. These run on global infrastructure. Think about Amazon, Google, Microsoft. They offer real-time performance, automatic scaling, and are accessible from anywhere. We don't need to worry about servers or storage. It's all taken care of. As you can see, databases have come on a long way, from flat files to AI-ready cloud systems, and you are stepping into this world at the perfect time. And that brings us to the end of this session 1. Let's talk about what you have just accomplished. You now understand what a database is. You have explored its key components and how it all fits together. You have seen the different types of databases, and you have walked through the evolution of databases. That's a solid foundation, and it's just the beginning. In the session 2, we will move from theory to action. I will walk you step by step through the installation of MySQL, setting up your first database, and running your very first SQL query. So if you haven't already, make sure to like and subscribe and turn on the bell. You don't want to miss what's coming next, I guess. Thank you for joining me today. I'm really excited to continue this journey with you, and I will see you in the session number 2. Bye bye.